In question number 1, it gives you cell notation A and B. Ask you to write cell reaction and the electrode half reaction. According to the convention, in the cell notation, the left side is anode and the right side is a cathode. Anode is oxidation reaction, so it's the zinc lose electron to form zinc 2+, or zinc lose electron, zinc 2+. In the cathode is the reduction reaction. The silver ion forms silver, so silver ion gain electron forms silver. So these are the two half reactions. To write the cell overall reaction, you add these two, but make sure the electrons are the same. So here you have 1 electron, here you have 2 electrons. You need to times 2 so that the number of electrons are balanced. And then you add these two half reactions. Add them together. Now, in order to find the standard EMF, you need to find the reduction potential. So here are the two reduction potential. Note that these are called the standard potential or reduction potential. Okay, note that even though the left side is anode, when you write a reaction, it's a reduction reaction because this is the potential for reduction reaction. Okay, so if we write both reactions as reduction reactions, the overall reaction, you should use the right cathode times 2 minus left side. Instead of add together like here, you minus because you write as reduction reaction. And that will give you the same overall reaction. Okay, you can either add these two or use the right minus 2 if you write reduction reaction. Okay, and the electrode, okay, the overall reaction cell potential is the cathode 0.8 minus anode 0.76, and that gives you 1.56. Similarly, in B, the left side is anode, the right side is a cathode. In anode, it's oxidation reaction, so it's lose electron. Okay, this lose electron forms cadmium 2+, and in the cathode is the reduction reaction. So proton gain electron forms hydrogen gas. You need the two of them. Now, you see in the right side, neither nitric acid nor hydrogen conduct electricity. To make it electrode, you need to add a metal so that it can conduct electricity. And the most commonly used electrode is platinum. And platinum is inert. Okay, it does not participate in the redox reaction. The redox reaction is just between hydrogen and gas and proton. All right, and platinum is just serve as a electrode. Compared to the left side, you have a metal, cadmium itself conduct electricity, so it is an electrode. Okay, but for any other electrode that only involves hydrogen gas, only gases, okay, solutions, you need to add a metal to make them conduct electricity. Again, just like in A, when we write half reactions, we can write as reduction reactions. Okay, notice that here we write reduction reaction because we need to find the reduction potential. All right, and here the two electrons are the same. So if we write as reduction reaction, you should use R minus left. Okay, so the overall reaction is R minus left give you this overall reaction, and the E should be cathode minus anode. All right, so minus 0.4. That give you 0.4. So that's the answer for this question. In question number 3, it asks you to design cells in which the following are the reactions in the electrochemical cell. As we know, electrochemical cell should contain two half cells, the cathode and the anode. So the most important thing is identify what is a cathode, what is anode. In A, the reaction zinc goes to zinc 2 plus. And this lose electron is a oxidation reaction, and that's a anode. The copper 2 plus forms copper metal and gain electron, and this is reduction reaction, which is a cathode. Okay, so when we write reactions, the half reactions, we can write both as reduction reaction. So even though this is anode should lose electron, we can write as a reduction reaction because this is the reduction potential. Okay, so those are reduction potentials. So the standard EMF, okay, the cell notation, we put anode on the left side, so the zinc lose 2 electron, and cathode on the right side, copper ion gain 2 electron. Okay, the two solutions are separated by salt bridge, use a double vertical line. Okay, we also can write, instead of ions, we can write as zinc sulfate, copper sulfate, which is in the question. So what is the EMF, the cell potential? Should be cathode minus anode, so 0.34 minus negative 0.76, and that give you 1.1. Similarly, in B, hydrogen gas forms proton, lose electron. That's an oxidation reaction. It's an anode. And silver is 1 plus here, forms metal silver, and that's gain electron, also 2 electron. That's a cathode. And when we write half reactions, we can write both as reduction reactions to find these reduction potentials. Now, when we write silver chloride half cell, we don't write silver ion. Okay, the reason is silver chloride is insoluble. Okay, when something is insoluble, we cannot separate into ions. We have to write silver chloride, gain electron, forms a solid silver plus chloride ion. And the cell notation, again, you put anode on the left side, cathode on the right side, because in the anode, the system contains gas phase hydrogen and solution phase hydrogen chloride. We have to add a metal inert electrode, all right, to conduct electricity. So platinum is a inert metal, serves as an electrode. And on the right side, silver conducts electricity, so it can serve as electrode itself. And also note that there's no interface between two liquids, and so here you have a solution. This is a solid, and therefore you don't need a salt bridge. For the electron cell potential, it's cathode minus anode, so 0.22 minus 0. Okay, and we can also here in the cell notation, instead of proton, we can write hydrogen chloride and silver chloride. In this question, it asks you to calculate the equilibrium constant for the redox reactions. To calculate the equilibrium constant, you need either standard state delta G or standard electrical potential. To find standard cell potential, you need to know what are the half cell reactions. In A, you have two half cell reactions. Tin goes to tin 2 plus. That's oxidation reaction. So this is anode. And tin 2 plus forms tin 2 plus, and that is a reduction reaction. So this is a cathode. Okay, so now let's write two half cell reactions. Okay, again, even though for anode should be oxidation reaction, tin should goes to tin 2 plus, but to find the half cell potential, reduction potential, you should write as reduction reaction, tin 2 plus, gain electron. Okay, these are the reduction potentials. Similarly, cathode is the tin 4 plus forms tin 2 plus. Okay, so with these two half cell potentials, we calculate E cell, which is a cathode minus anode, and that gives you 0.29. And now the negative RT ln K should equals to standard state delta G, remember in the last section, and this standard delta G equals negative NFE at the standard state. So with this equation, we can calculate ln K. Okay, and the K can be calculated. So that's A. Similarly, in B, you identify the two half cell reactions. Okay, again, the tin goes to tin 2 plus. That's oxidation reaction. So this is anode. And the silver chloride gain electron. So that's a reduction reaction, which is a cathode. So write the two half reactions, all right, and find the standard potential, half cell potential, or the reduction potential. And E cell is cathode minus anode. And ln K can be calculated, and K can be calculated.